Okay, number 4 is filling a conical tank. And so let me read it to you guys, and then we'll do the problem. Water runs into a conical tank at a flow rate of 9 cubic feet per minute. The tank stands point down and has a height of 10 feet and a radius base of 5 feet. How fast is the water level rising when it is at 6 feet deep? So we have a conical tank like this, and it's standing like this, and we want to measure something. So we have, we're interested in, and when you think about that, that's kind of like a right triangle, where the distance from here to here is the radius, and the distance from here to here is the height. And we're given that the radius base is 5 feet, and the height from here to here is 10 feet. And that's important, we'll need that. We're told that, let me read it again. It says the water runs into the conical tank. So we have like water that comes out of, like, I don't know where it comes from, a pipe or something. And so this is like the water that flows in. And then from here to here, it's filling up with water. And it says that the tank stands at a point, but the conical tank, the water runs into the tank at a rate of 9 cubic feet per minute. So that's a change in volume. And it's with respect to time. So we've got 9 cubic feet per minute. It says, how fast is the water level rising when the water is at 6 feet deep? So when h equals 6, we want to know the rate of change of the height. Does that make sense?
Yeah.
So now this is not overly complicated. We want to know dH dt, and we're given that dV dt is equal to 9 cubic feet per minute. So where do you think we start with this?
First, I think it's called a cone.
Do you know what conical means?
Cone.
Cone-shaped tank has the word cone, and we want to know, how do you calculate the volume of a cone? Well, if it comes to a point, you divide by 3, and then it has a circular base, so the volume of a cone is actually
1/3 squared.
pi over 3 times h over 2 squared times h.
That wasn't our actual box.
Cone.
And where I get this, it's actually, let me back up a second. This is actually the radius squared. Okay? That's the radius squared. But what we notice is that based on the dimensions, what do you notice about the radius with regards to the height? The radius is 1/2 of the height.
Yeah.
And if we were to apply the Pythagorean theorem, that will always be 1/2 of the height. So technically, the volume of a cone is pi times r squared times h, and then you divide it by 3, but r is equal to the height divided by 2. Now that's important because now that'll allow me to take the derivative with respect to h alone. So when I substitute that in, I get pi over 3 h over 2 squared times h. Now, if I do a little algebra, I can clean this up a bit, and I could say that's the same as pi over 3 times h squared over 2 squared, which is 4, times h. Which means that my volume is equal to pi over 3 times 4, which is 12, h squared times h, or the volume is equal to pi over 12 h cubed. And remember, we're comparing the change in volume with respect to time to the change in height with respect to time. So I just need to take the derivative of this whole thing with respect to time. So I get dv dt is equal to pi over 12 times 3h squared dh dt. And remember, what we're looking for is dh dt. That's what we want to know. And we were given what dv dt was, right? What was dv dt? 9. So I'm going to say 9 is equal to pi over 12, right, times 3, but we said that this occurs when h is equal to 6 at that point in time. So I'm going to say 6, times 6 squared times dh dt. So now, 6 squared is 36. What's 36 times 3? 90 plus 18, is that 108?
Yes.
Yeah.
Sure.
What's 108 divided by 12?
9.
Is it?
I don't know.
Try it and see. 108 divided by 12. I think you're right.
9.
Am I?
9.
Is
I
it
don't think I
9?
ever
Okay.
passed my 12.
So this whole thing
Elementary.
is 9 pi dh dt.
Yeah.
Divide both sides by 9 pi, and we get 1 over pi is equal to dh dt. Is that right?
Yep. Yes.